Yeah, I was looking online at Moodle, and I noticed there's a AR project that's due
Yeah,
on the
that's
21st.
basically what we are going to do. So I'm going to show you exactly that today. This is cisp363. The recorder is on. Let me just double check, make sure it is recording. Okay. So we are now in camera, and the final project is also in the last section, the last topic of this class on Moodle. And the assignment is called AR level. So the purpose of this particular application is to use augmented reality as a, kind of like a level or a plumb line. So you can use it to kind of line up stuff, okay? You will have to superimpose two lines on top of a camera preview, one to display the horizon, and then the other one to display a plumb line, which is just a vertical line. But that has to work, whether you're tilting your camera a little bit or your mobile device a little bit, or whether you tilt it up or tilt it down, or swivel. So that's it's useful. It actually is useful for various purposes, like if you want to put up cabinetry and stuff like that. It's useful. Picture frames, useful. So that's it actually has some actual application to it. It's going to be a composite of several projects that we have done so far. So what I'll do first is to talk about what the project is about, and then we'll look at all the components and point out what you need to borrow from which project to get this one done. Okay. So we'll start with the description of what this particular app is going to do. Write an augmented reality app that superimposes a level line in a camera preview. When you're done, zip up the files in the project folder, just like with the previous project, and upload the zip file over here, which means the assignment upload interface. This project includes a few past programs that we have done, okay, that I have written in class. They will be made available to you, so you can actually borrow code from past projects and present it that I have written and presented in the class. First, there's a program called Test Draw that I did quite a while ago that shows us how to display or draw 2D items in the custom view. Okay, so that's one project. I will show you all of these later. The second one is TestCam, which is our most recent application. It really just shows a preview of what the camera is seeing. And then the last one is Test Sensor, which shows us how to make a connection to a sensor. Now, Test Sensor only makes a connection to the light sensor, but making a connection to the orientation sensor is about the same. Okay, the only difference is you have to identify the type differently, and when it changes, it comes back with more than just one single value, because an orientation is in 3 axes, so you will have multiple values in that case. So this is what you need to do with your application. Use a particular activity to start an app, and the first activity that you use, or the first screen, should not display the AR view. In other words, this one is just a splash screen. You start it up, it displays either a logo or a description, or a combination of stuff that you say, okay, welcome to AR level or whatever. But it's not going to be the activity to get into when you want to display the level. So when you're in this activity, or when you're starting up with this activity, the first thing you need to do is to check to see if all the necessary hardware components are available on your device. So you will have to check whether there's a camera, and also whether there's an orientation sensor on your device, on your mobile device. If any sensor type is missing, just stop, report the issue, and say that your device does not have a camera, so augmented reality cannot work, or your device is lacking a orientation sensor, and that's why this application cannot work. Okay, and stop there. There's nothing else to do. On the other hand, if all the sensor types are available, you want to present a button to enter the AR view activity. So this is the second activity of your application, which actually shows the camera preview with the 2 lines superimposed on top of it. Are we doing okay so far with the description of the app? Yep.
The vertical line, it's not like in a 3D view, it's just a vertical line.
It's just a vertical line, but it has to reflect the right angle So when your camera is tilting, your vertical lines should still stay vertical.
So it's pretty much just bound to the horizontal line as well.
It's not necessarily bound to the horizontal line. So the horizontal line is the horizontal line, but the vertical line, when you look up a little bit like this,
Yeah.
okay, so it's not. You can download one of those virtual augmented reality level app and see how they do it. But basically, the vertical line should always line up with an actual vertical line in your camera, and then the horizon should always line up with a horizontal line in your actual camera view. Okay, imagine that you're at a beach and you have a plumb line in front of you. Okay, so when you look through your application to the plumb line and also the remote horizon, they should always stay lined up with the actual plumb line and also the horizon. So that's the objective. So your camera can tilt, it can also rotate, but whatever you do, as long as it is within a certain range, so you're not changing the orientation, the line that you display on your screen should remain aligned up with the actual vertical line and also the actual horizon. Okay, so that's the objective, because the application is is basically a virtual level, and those are the things that we want to do. All right, so in the AR view activity, which means you check there's a camera device and there's also an orientation device on your mobile device itself. Then you can switch to the AR view with a click of a button. So you also need a tail of two activities, or there's another app called two activities or something like that. So you need to know how to switch from one activity to another activity within the same application. So that's the other program that you have to make use of. Inside this view activity, we'll use a frame layout as a container for all of the views. There's no need to display any text on it. There are no additional buttons in your app, so that makes the user interface or the activity pretty easy to deal with, because it's really clean. It's just the superimposed two lines on top of the preview of your camera. But the trick that we have not really talked about is how to size the frame layout based on the proportion of your camera preview. In other words, you're not going to use the proportions of your activity screen itself, you're going to use the proportions of your camera itself. So you will have to get the horizontal resolution versus the vertical resolution of your camera, and we'll talk about how to do that next. Okay, there are easy ways to do that. So you have to use that in order to size the frame layout. And then you will use another view to draw the lines and whatnot. Well, in this case, we only want to draw two lines on that screen, and that should be displayed on top of the preview window. And the view group can be used, to do that, to add basically multiple views. I double checked on this, and I tested this yesterday, and it was pretty easy. I mean, once you have the two views, ready to go, you just have to add both the views to the frame layout. And if you do it in the right order, or if you specify which one is on top of which one, that part can be done just like that easily. One thing you also have to do is to find out the coverage angle of your camera. In other words, because you want your camera, when you tilt your camera, you want the horizon to stay with the actual horizon. So that means you have to find out how to map that horizontal line with your preview. Am I making any sense? Okay, I'll give you a side view of what I'm talking about. So let's say this is you, and your camera or your mobile device is tilted down a little bit like this. Okay. Well, that's a little bit too much, so I'm going to add a little bit more line to the device. And this is the actual horizon over here. So when you look through the camera to the horizon, it is not going to be at the center of your preview anymore. So you have to move the horizontal line accordingly so that it remains lined up with the remote horizon. Am I making sense here? Okay. So what you need to do in that case is to find out what is the view coverage or what is the angular coverage of your camera. And that part is reported as a parameter of your camera. So it's very handy. You can find it out, by just looking up the parameters of your camera. And then you have to look at the actual orientation of your camera. Okay, so using the orientation sensor, you can see how far it has tilted, and use that to adjust how to display the horizon in the preview. Are there any questions about the math aspect of this application? Okay, another way to look at this. Let's say this is the actual preview, and you're standing on the beach, looking out, to basically infinity, the horizon. Okay, so if everything is lined up, and your camera is, or your device is, pointing like this, is square, then the horizon should be like this, and then you draw your artificial horizon to basically overlap with the actual horizon. On the other hand, if you're looking down just slightly, if you tilt your device just ever so slightly down, then you will get a slightly different view, okay? Because the ocean will take up more space on the camera, okay? So you want to do the math so that your actual line, the artificial line that you're drawing to represent the horizon, stays lined up with the actual horizon. Okay? Are there any questions about this part? Now, so what you need to do is to find out, okay, exactly how far is this coverage, okay? In other words, if this is at 0 degrees, okay, vertically this is, pointing right at horizon, what is this top part here? In other words, what is the angle of coverage, vertically, from here, from horizon to up, and from horizon to the other end? That number is reported to you by camera.getParameters, okay, which is very handy. Likewise, the other one is also reported to. So if you look at your camera, it is pointed straight, at front, right to the front. The other angle coverage is also reported as well. So you will need that information to make your application work, because you want this horizontal line to stay, basically straight with the actual horizon, lined up with the actual horizon. Are there any questions? No questions? So, okay, this is a hint, okay? You'll probably have to use sine, cosine, and tangent, or tangent in this case. Because, let me use a color that actually works. Okay, so here is the actual screen. This is your eye. And this is the actual angle of coverage of your camera. Okay? If the horizon is over here, okay, if this is the actual line to the horizon, then you will have to figure out how far from the top or how far from the bottom is the center of the horizontal line in your camera. It's not going to be a horizontal line, because if you rotate your camera, this horizon has to shift as well. So you have to take all of that information into consideration so that your horizon stays lined up with the actual horizon when you tilt your mobile device, and also when you rotate your mobile device. Panning doesn't change a single thing, because when you pan, it doesn't affect the horizon at all. Are we doing okay so far with this part? Okay. So we will take a look at camera.getParameters, which is a method of a camera, and that can give you all the parameters that you need in order to do this to do all this math. Okay. You want to put two lines in a frame layout. One line to show the actual vertical line, which is kind of like a plumb line, and the other one to show the horizon, which is a horizontal line. Make these lines stand out using a bright color. Okay, so instead of using some really dark color that does not stand out, use bright yellow. Okay, so change the color to
Fluorescent
something.
neon. Fluorescent green.
Or alien green. Yeah. Alien blood green. That would work. As the orientation changes, okay, for the most part, I don't care about the panning part, but as far as rotation is concerned and also tilting is concerned, change and update these two lines so that at any time a user can see the true horizon and the plumb line. Note that using a canvas to draw something requires you that you clean up the previous drawing before you draw something new. And to clear something that you have drawn already on a canvas, you can also click on this link here, and that will show you how to do it. You're basically going to paint the entire canvas with quote-unquote transparent paint. So that will basically erase everything that you had earlier on that canvas. Then you can draw something new on top of it. Okay. Okay. Is everybody clear about what the project is about? That you have basically a week to do. Okay. There are components that you can borrow already. Okay. So what you really need to add is basically stitching all the pieces together. Okay, because each piece it will be linked to other pieces. Okay, so what I'll do first is to show you, what pieces we have done so far, and I can upload all the code that I have done in this class, so you have a starting point for this particular project. And I know that they recently updated this, so I'm going to go to SDK tools to update mine first, just so that it doesn't complain later on and say, well, Tech, we got some updates, and yours is not updated. So we'll go ahead and do some updates. Install. Okay, so I'm done. Close that. And then Eclipse, has a recent update as well. So when you get into Eclipse, you'll definitely check out the updates in Eclipse. So I'll do the updates first, and then we'll go into the individual projects that I think will be helpful. You are more than welcome to start this project from scratch if you want to. In other words, without borrowing any existing code. I personally would not, just do a copy and paste of the files that I have done already, because that might prove to be even more trouble than actually working on the individual projects. But let me check for updates first, get my Eclipse up to date, and then we'll get into the individual projects that are going to be helpful. Alright, so there are a few updates, nothing major. I did this yesterday on my own computer, and it's not an issue. Okay, yeah, good. Okay, so there are several projects here that will be useful to your final project for this class. The first one, obviously is test cam, test camera. That one will give you the code to do a camera preview. Okay, it will also show you the code to attach the camera preview view to a frame layout. Okay, so that's why this is going to be useful. The second one is test draw. Test draw, let me just open up the project and show you, which part of it is useful. When you go to the source code, it has a particular class for drawing something. So in this case, we have text view being a special class. It basically uses a canvas to draw something on the screen. So on draw, I have set color, draw circle, and on touch event, I have something else. So you will have to borrow some code with this one to basically draw the horizontal line, or the line that is representing the horizon, and also the line that is representing a imaginary plumb line with this code here. Okay, so this is the second one that you have to kind of borrow code from. The third one is test sensors. Okay, that one is kind of obvious. Because test sensors is useful in order to test whether a particular type of sensor exists, and if so, how do you get the sensor, and how do you get the sensor to report, okay, there's some recent changes, okay, the orientation has changed, do some updates on your screen, okay. So this will be useful as well. Test sensors is going to be useful. And then the last one is going to be tale of two activities, because this one shows you how to start one activity from another activity. Okay, so all of these 4 projects or 4 individual kind of sample programs will be useful for your final project. Are there any questions at this point?
Where is the test draw?
Test draw is, well, I'm going to make all of this available. I'm going to zip up the entire workspace and put it onto Boodle.
I was going to say, we're just going to have a tarball.
Hmm?
We're just going to have a tarball to download.
I'll just put a zip file because many of you are using Windows. So if I make a tarball, then you'll just go like, I don't know what to do with a tarball. So I'm going to use a just a regular zip file to do it. Okay. So are there any questions about which sample program that we have done so far is useful for this particular application?
I would assume the ones outlined in the specifications.
Well, the ones that I just mentioned, right? I mean, so those would be useful for this particular project. And I want to show you how to kind of import something. It's actually pretty easy. If you have test draw already imported into your project area, your workspace, and there's one class that you want to borrow. So let's say you want to borrow text view, okay? Which probably is not a good name in your project, so you might want to change the name of that class to reflect it is your view. So what you can do is to right-click on the Java file itself, do a copy, and then go to the other project where you want to import it to. Go to source again, but don't do it under source. Do it, at the package level, and then do a right-click, and then click paste. So this way, I'm copying and pasting that particular class in the entire file from one project in the workspace to another project in the same workspace. So it works out really well. I tested this yesterday at home, and it just works. It works fine. Yep.
So and then if you want to use anything that's in that class, do you have to use the imports to do it?
No, because they're all in the same package.
Okay.
That's why I said, make sure that you do not paste in SRC, because if you right-click on SRC and then paste, it will create a new package called the default package, and then you will have problems finding that particular class definition. If you do it inside, then it will be fine. Or if you right-click on the package itself, which is what is highlighted here on screen, and then you say paste, then it will be pasted into the package. Everything within the same package they don't need extra imports. Okay, and that's the nice thing about you putting it inside of that particular package.
So pasting it into source sounds like something you did from experience.
Yes, because I tried it out, didn't quite work out the way I wanted, and so I warned you guys against it. Do not do it that way. Yep.
So what's the final on the 19th?
The final on the 19th is just going to be, I'll be here for 2 hours. You can come here for 2 hours, but there will be no final exam for this class. It's just going to be the final project. But you're more than welcome to come here to work on your project. So in case you have any questions, especially regarding the math of how to do the calculations and stuff like that, you can ask those questions during those 2 hours. So it's more like an extended office hour, for this class. Why?
Extended office hour while tech plays on the computer. Wait, that's wrong.
Well, I think this is going to be a fun app. I mean, this is an app that can be extended easily to be something that is worth money.
But they made the glasses are now available to the public. The Google Glass.
The Google Glass?
Yeah, you can buy one for $1,500.
Still the dev, version though.
It's the Explorer version. But they opened it up a month ago or so, and they mass buying spree. So they decided just to make them available until they run out of stock.
Ocular Rift. That's better because it's stereo vision. Except you cannot really see out of the actual. So it's not good for Well, it is good for augmented reality if you mount the cameras on the Oculus Rift device itself.
I've been waiting so long for a product like Oculus Rift.
Say again?
I've been waiting so long for a product like Oculus Rift.
Well, apparently the Norwegians here have been waiting for it as well.
Well, what's funny about things like, like the Oculus and even Google Glass is they're based on technology that's 20 years old.
Well, it's not about the technology. It's about, can we make it inexpensive enough to make it, like affordable to everybody? That really is the question. Because laser printers came out how many years ago? A lot of years ago. I cannot remember,
80s.
like 20, 30 years ago. But when they first came out, one, they were super big, so even if someone was to give you a laser printer, brand spanking new, one, you will not have the space to put it, and two, you will not have the circuit in your house to run it because it just sucks up electricity like there's no tomorrow. But these days you can buy one from Fry's for what, $65 or so, or less. Okay, plug it into any plug, and it's Wi-Fi enabled already. You don't need to wire it up. You just press a button here, press a button on the router. It automatically pairs up, and it gives you the software to run on a PC to find it and install the driver automatically, and you're ready to go. So it is not about the technology, because the laser printing technology is ancient by today's standard, but it is about can we make it inexpensive enough and accessible to the public to basically mass produce it to lower the cost of manufacturing. So that really is the question.
Well, the process of it, the general scope of it was done a long time ago, but the technology that putting into it now to make it so most people don't get motion sickness and stuff like that was not really there, and you don't want to have like a large screen in a display.
That is amazing. I've actually been in a tank, and driving through a window that is this big, or using a screen that's like this big, it's extremely difficult.
Well, this is actually just a stopgap, between driving in a tank and having the tanks remotely controlled. I mean, that's just going to happen. I mean, I cannot see that not happening within the next year or two.
I want to see it remotely controlled, and someone just puts white noise, white radio signal all over the place, jamming all signals.
Well, then we'll make it autonomous. Worse. Now it can find its own target and do its own thing. You just have to give it a high-level objective, and it will do it.
In fact, I'd like to introduce you to something called Skynet.
No, at some point, if Skynet is smart, it would just say, well, forget this. I'm leaving the planet.
It's not worth the resources.
It would be like the dolphins in the Hitchhiker's Guide to the Galaxy. It's like, thanks for the fish. See ya. In this case, it would be thanks for the silicon. See ya. But this is where things are going. And you can imagine a pairing of the Oculus Rift and something like an Android mobile device is inevitable. I mean, this is going to happen. It's just a matter of who's going to do it and when it's going to happen. Is the marriage between an Oculus Rift type device, doesn't have to be exactly the same brand or the same make, but it's a similar device. It's a basically it's an overhead projection. It's, how do you call those things? It's called a not overhead.
What about a visor?
Describe it again.
No, just the Oculus Rift device used in this application. There's a particular name for that. Head-up display. That's it. So it's going to be a head-up display. Running, possibly the Android operating system, but there will be an extension to the operating system or to the framework, because now that you have two screens that are individual or independent, now you can have an extension to the framework to deal with 3D object projection. Okay, so once you add that, and also eye control, what is the focal plane that your eyes are looking at and which direction it's looking at, they can integrate all of that stuff into the new version, whatever version of Android, API, and that will become an interesting, combination, because now you have the typical, app framework that we have been talking about in this class, but on top of that, you also have, stuff that that is lacking with a touch-based interface. Okay, because you can't really touch and click something with your eyes. But what you can do, I talked about this, in previous classes already, is to change the focal plane of what you're looking at and by changing that, you can say, okay, I'm looking at a virtual point that is sticking out of an actual object from the outside view, and you can use that as a trigger mechanism and say, I want to select that particular object. Yep.
I think
because it is really, really, really irrelevant, or is it because you forgot what you wanted to say?
I thought it was a funny joke at first when I thought about it. I was going to say your eyes could be touched something. They're called butterfly kisses.
the interesting thing about something like the Oculus Rift, though, is that it provides depth of field because you have stereoscopic vision.
Exactly, and that is something that is still missing from Google Glass. Right. Because if I remember correctly, Google Glass is still a single eye projection.
Right.
And but the nice thing about the Google Glass is it's not opaque. You can actually still see what is going on in reality. It's just displaying some additional information on top of actual reality.
Yeah, from what I hear, the Oculus Rift is going to maintain a focus of infinity for a while now.
Well, it's just for a while. It is it's only a matter of time before they can change it. Exactly, because once they can track eye movement, in other words, once they can track your individual eyeball and see how you're using triangulation, they can kind of guesstimate the focal plane that you're at. They can change the focusing of the individual eyepieces to simulate you're looking at a closer object or you're looking at a far object.
I thought they already could do eye tracking.
Yeah, they
with the precision that is needed.
I don't know about that.
No, they can do eye tracking. The eye tracking mechanism has been done.
No, I mean the precision.
The precision is high enough that Stephen Hawking was able to use it to type. Or to operate computers.
I know they have like they showed an example of like a LCD screen roughly this size and having millimeter accuracy sitting back out like this.
You will probably need some higher accuracy than millimeter. I mean, if you want to see the convergence of the lines from both eyes, you need a higher resolution. But they will figure that out. I mean, that part is not the issue.
See, that picture right there is interesting to me because
it's up here and it's a tiny little device. So normally you just see out of your regular glasses, except occasionally you just kind of look up and you see the information displayed by the head-up display.
See.
Yep.
Would you get like extreme short-sightedness if you just wore the Oculus Rift?
No, because the lens system is designed so that what you're seeing, it appears to be at infinity or 50 yards or whatever distance.
So your eyes would actually look into infinity?
Yes, as far as your eyes, the focusing of your eyes are concerned, you're looking at something close to infinity, if not infinity.
So everything will be crisp at whatever distance.
That makes sense.
It's like if you're inside of a game, like if you're playing a game where you can see.
And it's the same way with the Google Glass. It has a focusing mechanism. So when you look at that little window over here, that display would be almost be focusing at infinity. So normally you're not gonna have to cross eye and really focus, because otherwise nobody's gonna buy it.
Well, see,
especially people in their 40s and 50s. I cannot focus that close anymore. I mean, I can.
Well, my question would be though is how is that actually going to affect people's eyes? Because normally you can't focus at infinity, right? You can only go so far as your vision will allow you to go, right? But with augmented reality or things like Google Glass or Oculus Rift, it's basically augmenting your vision because it's allowing you to focus at infinity because those things really aren't that far away. So I wonder if it will actually end up degrading vision eyesight.
No, I don't think so. I mean, in fact, this will be better than looking at a screen like this one, because this a normal screen or normal laptop or mobile device is even worse. Is at the most at arm's length, which is about 2-3 feet or so. With a mobile device, because it is so small, we kind of hold it like about this distance. So that's about 1.5 foot, maybe. Okay, so your eyes are forced to focus at its distance at about 16, 18 inches or so, which is not normal for your eyes are not designed or evolved to focus at that distance the entire day or the majority of the day. Your eyes are designed or evolved to look at more distant objects for the most part, 20 yards or more, because after 15 yards or so, it's pretty much quote unquote infinity unless you use a telescope or a monocular, then you have to focus it. So something like this, is actually better for the vision, from that perspective, because even though it is close to your eye, but when you look at it, it is appearing at a distance of 20 yards away.
So it's basically tricking you into
it is tricking you.
Focal point.
Exactly. But what this is not doing, what Google Glass is not doing, but Oculus Rift is doing, is with this one, unless you can know the exact position of the projection, you can't really do augmented reality with this one. You cannot superimpose anything on top of that to say, oh, okay, that object that you're looking at, it is a hamburger joint. Okay, it's a shop, and it is rated 4.5 stars. Da 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 da. There's no way, because it doesn't know, the application does not know the actual position of the device relative to your vision, to your view of vision. So there's no way that it can actually superimpose things in the case of augmented reality.
And isn't the
with this one it can.
Google Glass limited in resolution?
Yeah,
It's like a few hundred pixels.
Well, they're using like a.
That is completely artificial, because it is very inexpensive to make a 1080p resolution device when your projection is only about this big, because that is already magnified. The actual projection device, or the actual device or raster device that is producing the image, is going to be a lot smaller than the screen itself. It is using basically optical lenses to make it appear to be about this big, on top of your regular glasses. So getting 1080p resolution is not going to be that difficult nor expensive. But the problem is you can't really superimpose anything, because you don't know the relative location of that thing relative to your own view. And then Google Glass also does not have a camera on top. Well, it does, but it doesn't know how to overlay the image on top of what you're looking, because it doesn't know through that window what is the exact view that you should be seeing. Whereas with this one, it is completely covering your eyes. So if you put cameras on top of the Oculus Rift, especially if you put 2 cameras on top so you can get a stereo view, this is a much better platform for that sort of application. For augmented reality, the Oculus Rift is actually a much better platform for that.
Plus, trying to do augmented reality on Google Glass would just eat the battery, wouldn't it?
Yeah.
Well, yeah, but we can always make a backpack.
Everybody will have cables running to their back pocket.
Yeah.
Well, when I first saw the Oculus Rift, I know this is going to sound funny, but I mean this. It reminded me of, or it made me think of what prototypes for Jordy LaForge's eyewear first looked like, because of the possibility of this technology.
Well, Oculus Rift beats Sony to the market. So if they do it right, or if Facebook does it right, they can.
I was upset about that at first, but to be honest, I think that I was reading an article that was written, or that somebody did an interview with, I can't remember his name, the guy, one of the founders of the company, and he said that it actually makes sense for them to not go with someone like Glass or with Google or Sony, somebody who's already in that space, because all they're going to want to do is try to adapt the technology that they.
Yeah, they would dismantle the company and the teams, instead of keeping it intact and say, okay, we own you, but you do your own things. We don't really want to get into
what
the
Facebook
business.
is doing.
Yeah, Facebook, is basically looking at the entire package and say, okay, we still want to keep you as a team. It's just that now we own your stock and yeah.
Well,
but with Sony, Sony's going to take the whole team apart and basically just extract the patents, and possibly a few engineers and the software, and that's it. The rest of the company will just be dismantled and sold
So
to someone else.
Facebook is keeping the company independent.
yeah, it's staying.
But Facebook has no choice, because Facebook itself does not have any type of Ocular Rift type of development, as far as I know. If they do, they might have been in the infancy, in the stage that they would just kind of give up the internal team and just say, okay, now Ocular Rift will pick up from that.
We got to look at it like this. Oculus, basically, with $2 million, did what it probably took Sony and Google, couple, like tens of millions of dollars to do.
Well,
so what I think from Facebook's point of view, it's like, well, why screw with something that A, we barely know about, and B, there's already a good team. So it just makes, from a management perspective, it makes more sense for them to stay together.
Well, it'll be interesting because Facebook has been buying companies like WhatsApp and Ocular Rift, stuff like that. And so it's positioning itself to really go head to head with Google.
Oh yeah.
And the big players. I don't see Microsoft anywhere close to doing anything like this. Not Google Glass, not Ocular Rift, nothing at this point.
10 years from now is what they'll be doing is developing their first one.
Well, but what Microsoft does have is Kinect.
Yeah.
And Kinect, the way it is right now is just a gaming console. It's more of a widget than anything else. A lot of people do not use it, do not like it, don't want it to be packaged with the the bundle.
Yeah.
But it is a very interesting kind of device because it does give the device a way to see the outside world, or at least the near space, in 3D, and that can be very useful for applications like augmented reality, because it can recognize your hands, near field. It can see things.
I've actually seen like product demos of it and stuff, and the Xbox One's Kinect is stereoscopic, and it's crazy what it can do. Like, it can track based on skeletal structure. It can track based on facial recognition. Like whenever you.
But that would be like 3D type of facial, not the image of the 3D of a face.
Right.
Yep.
So it's really cool.
Go ahead.
Yeah, the Kinect is nice, but it looks like it's lacking. It needs to have like an additional Kinects positioned around to
they might
capture
interfere
more information that is not being captured. Because right here, any information right here is just missing.
Right, because it's a shadow.
Yeah.
So basically what Kinect is what we call a LiDAR. It's kind of like a radar, except instead of using radio wave, it's using infrared radiation. But it's still using time of flight to get a depth information. And as a result, it can only do so much. It's not based on what we usually do, because we use stereo vision. We process the differences between two images to basically get a sense of, okay, what is at what point. And with Ocular Rift, okay, just kind of think about Ocular Rift, and you just basically add two cameras sticking out, from two sides of this one, and it actuates. Okay, in other words, when you put that thing on, and without moving your head, if you move your eyeball, the external cameras will kind of move with that motion. That will become a very interesting platform, because now whenever you change your view, the camera would do the same thing and change its orientation, and so that means no matter which way you look, whatever you're seeing inside the Ocular Rift will still be a truthful representation of what is outside and what the camera is actually seeing in 3D. And that makes augmented reality much easier to implement, because you're not overlaying. You're actually, you have those images to begin with. You're not just overlaying on top of what your eyes are actually seeing from the outside.
But how would that work? Because when you move your eyes, you're actually looking off to the side, but if the display is right here, even with the high field of view, then you're encroaching in an area where
you'll be running out of screen area. Is that what you're talking about?
As long as the screens cover up the entire eye space, then you're fine. So like as long as the screen does something like that, like where it wraps around here and around here, then you're fine.
Think of it like this. Okay, let's say this is your eyeball. Okay, we have a view of the center part, that actually the only part that really matters, has an angle of about, I would say it's about 80 to 90 degrees or so. Is that right? I think that's about right.
Peripheral vision?
Including peripheral vision, it's probably about 120.
Right.
So if you extend to include your peripheral vision, which means you cannot really see what it is, but you can sense motion, with that extended range, it may be 120 degrees, which is I think it's a 16 millimeter lens in 30 millimeter, camera terminology. That's the coverage of ultra wide angle lens. So it's about 120 degrees. So when you, without moving your head, and you kind of roll your eye, side to side or up and down, you're moving that 120 degree screen, so to speak, around. So inside the Ocular Rift or future versions of the Ocular Rift, what they can also do is to have that projection screen to actuate. So when you roll your eye up, left, down, and whatnot, that portion of the screen will also kind of rotate and shift according to your eye movement.
Well, they wouldn't even have to do that, because if you think about it, the more moving parts you add to something, the more likely it is to break. Yeah. And so
you will have to, but then you have to have a much larger screen to cover everything.
Organic LEDs.
Well, that's
what they're doing in the second development for the Ocular Rift.
But you have another difficulty, because the screen will be so close to your eyes, you can't really focus that close. So that means you need to have a lens on top or next to the screen to give you to basically do the focusing for you. So it will be kind of like a loop in front of you, and you're looking at a very tiny little screen that has super high resolution, right? But that thing cannot stay immediately ahead of your eye the entire time, because as soon as you roll your eye, that thing has to follow your eye and go in different directions. And that's why you cannot just have a much bigger screen, because we can make a bigger screen, but can you focus to a screen that close to your own eyeball? You cannot. Well, I cannot. If they want me to buy that thing, I cannot buy it if it's just a screen that is close.
Have you seen the firefighter suit for Sweden?
No.
They have the whole helmet thing with the heads-up display.
Yep.
If you look up, you can see it.
What is it again?
A firefighter's suit for in Sweden.
Swedish.
Yeah, I'm able to focus at this distance. And you close their blurs.
And
the suit. Yeah, that's the one.
See, the thing is I don't, with augmented reality, I want it to make, people who wear glasses, for instance.
Well, it looks like
yeah,
that looks like
Yeah.
that looks like something from
It looks like
from
Judge
a Japanese anime.
You know what? It looks like Judge Dredd. Or, you know what?
Well, Iron Man.
From Metal Gear Solid.
You know what it really looks like? It reminds me of the hollows from Bleach.
Yeah, exactly. Yep. But that's going to be, this is where things are going. I mean, I know we are talking about, Android devices that are flat, that's your phone, your tablet, and we are only, making a homework assignment out of, okay, let's display just the horizon and a plumb line, on top of a camera preview. But this is, what, things will be, there's no stopping it at this point. This is where things are going.
If I was in a fire, just expounding upon this, and somebody came in looking like that, I mean, the anxiety level is already really high.
Yeah, now try to rescue
this
small
person
kids,
right here.
they'll be running away.
I think if I were in a situation like that, I wouldn't care. It's like
they look like drones from the Clone Wars.
Yeah.
Well, but you have to look at the comments.
droids.
Lack of visibility makes it hard to spot victims. Over complexity makes it harder to save lives. I've had the honor of learning from masters of rescues, going through
Typo.
bad typo too, how they face every day that more than once, and so on and so forth. It's the same thing that people or pilots talk about when drone first came about, all the pilots, real pilots that wants to sit in the cockpit, they say, oh, this cannot replace what we do. Well, yes, it can.
I actually know a guy who flew Apaches in combat, and they actually use a version of augmented reality.
Well, Apaches were one of the first actual, application of, full HUD. I mean, because they have night vision that is tied into the Gatling gun, and wherever they turn, wherever the helmet turns, I think the Gatling gun turns with it, right? That's one of the features of the Apache. It's a standout, kind of, it's a feature that's really stood out because the earlier attack helicopters did not have technologies like that. But getting back to our application, are there any questions about this application?
What were we talking about?
All we are doing is this, okay? Let me see if I have an app like that. I probably already have an app that can do the plumb line thing.
Is that plumb line as in like the horizontal?
A plumb line is the vertical one.
Oh.
Yeah, because when you go to a hardware store, you get when you purchase a plumb line. So it's basically just a really heavy weight, that is usually pointed at the bottom with a loop here, and you attach a string to it, and then you just tie the string up with some place. So the objective of a plumb line is you can see the vertical line, that has to be vertical, that has to be like truly vertical because it is done by just a heavy weight at the bottom. So that's the plumb line. So this is one of the virtual lines your application has to display. The center of the plumb line and the center of the horizon, this center here is always staying the same, which is the center of. Well, I take it back. I take it back. In your application, the horizon is always going to match the actual horizon of reality. So that has to basically float with actual reality. The center of the intersection here is going to be at the center of your entire preview. So that's basically how I want the application to be set up.
So we assume that the device is going to be held like this, and no one's going to be holding it like that.
That is correct. You can make the assumption that you don't have to handle basically rotation all the way. Yep.
And for the horizontal line, do we have to do from 0 to 90 degrees, minus 90, or?
The horizontal line and also the vertical line, they have to go from one edge of your view to the other edge of the view.
I mean, when we move the phone,
yeah.
Does it have to hit the top of the screen when we hit 90 degrees up?
Right.
Oh, okay.
Basically, it's a reticle.
Yeah, it has to cover the full range of the view of the camera preview. So your horizon can appear as low as here when you tilt your phone up, to that extreme, and it can appear as high as here when you tilt your phone all the way down when the horizon is just barely visible from your camera preview.
Oh, so basically the horizon needs to hit the screen itself.
Right.
If it is not 90 degrees.
Yeah. If the tilt is out of the range where the horizon is no longer visible, you just don't paint it, don't draw it.
Oh.
And then the vertical line should always be there unless you're going straight up where there's no vertical line anymore. So you can basically just define and I'm going to simplify this a little bit for you guys. If the horizon is not visible, don't bother with the plumb line here. So only display both the plumb line and the horizon when the horizon is within the view of the camera preview. That was greatly simplified stuff because all the exception cases of when you look straight up, it doesn't make sense to have a vertical line anymore. So so you have to cut it off at some point. So I'm just make the cut off where if you cannot see the horizon, don't bother with the plumb line. It doesn't display anything at that point.
Just start message.
Display error message.
There was an angle ruler on the right or on the left, which will tell you how many degrees you're above horizon. Is that right?
You mean like a scale? Like
kind of thing, yeah.
You don't need a scale. I mean, if you want to display a scale, that's okay with me too. In other words, some of you may want to display a scale like this is 10 degrees down, this is 20 degrees down.
Yeah, all the way to 90 and then all the way to
I want my mule dots.
and little bitty invaders will drop down on the screen if you tilt it up and you can tap them and shoot them.
Yeah, I want my mule dots. Range information. Yeah. And by the way, most people think mil dots, the mil refers to military. That is so wrong. It's a milliradian, millirad. Yep.
Is all the sensors that we need for this, in terms of other than the camera, of course, is that just a Celeron meter?
You need the orientation sensor. Okay, so I'm going to go into the individual pieces of information that you need for this particular project. So the first thing you need to do is to use camera get parameters, because that's how you can get the actual angular coverage of your camera. So if you go to the camera web page here on the Android website and just go for get parameters, that will give you most of the information, if not all, regarding how wide of an angle is covering in each axis of your camera. So that's one thing you have to do. And then the second thing you have to do is to go to Android sensors. Android sensors. Sensor is fine. You go to the overview, and then you just look up orientation. And this is deprecated, okay? And but since it's deprecated as of API level 8, don't use it, but instead use get orientation. So when you use get orientation of sensors, okay, of sensor as a class, this is a static method. This is not a object method here. It will come back, with the azimuth rotation around the z-axis, which is this one here. It will return the pitch rotation around the x-axis. So the x-axis is that one, so that's basically pitch, and then rotation around the y-axis is this one here. That's the one. The row is the one that we don't need to pay attention to. Yep.
So it returns an array of floats.
Say again.
Like
yes, it returns an array of floats.
Well, 3 arrays.
So there are two arrays that it returns. Okay. So when you look at the 2 arrays, one array is called values, and these 3 are related to values. R is, let's see, what is R?
Is that
R is
rotational?
a rotation matrix.
Yeah.
C get rotation matrix. And then values is an array of 3 floats to hold the result.
What's the purpose of a plumb line if you already have the horizon line?
You can see how far, like, left
just
or
in
right
this
you
kind
are,
of-
basically.
Oh, okay.
Because stuff that you want to align vertically may not have a perpendicular line for alignment with the horizon sometimes.
And a plumb line will allow you, regardless of left or right orientation, to have whatever you're looking at aligned.
So it gives you kind of like a relative, like,
So let's say you're looking at a tree and you want to see if the tree is growing kind of straight up or whether it's slanted at a slight angle. So what you can do is to use an application and you just look at the tree. But the tree sometimes doesn't have any perpendicular line to align with the horizon, especially when the tree is growing on the slope or something like that. So you need that plumb line to see if it is vertically aligned, because you won't have any aid for the perpendicular line. When you look at a picture frame, yeah, if you get one, you get the other one, because a picture frame typically is square or is a rectangular with right angles. So you can, if you have a horizontal line, you can get the alignment done. If you have a vertical line, you can get the alignment done. But with certain objects, you don't have both horizontal and vertical lines, so that's why you need both in your application. Yep.
It's pretty crazy how, like, when you get down to it, it's actually very simple technology that allows you to do orientation.
Well, it's simple and it's not so simple, because this one will give you the row as well, and that has to use a compass. So this is integrating both sensor types. It's integrating information from your compass as well as your accelerometer, and it's combining all of those information into one. Yep.
It has an input for a rotation matrix. What would that be?
You mean this part here?
Yeah.
The rotation, okay, computes the device's orientation based on the rotation matrix. When it returns the value, is going to return the stuff, and then R is a rotation matrix, get rotation matrix, C get rotation matrix. Okay. Get rotation matrix computes the inclination matrix I as well as the rotation matrix R, transforming a vector from the device coordinate system to the world coordinate system, which is defined as a X is the vector product XY. Oh, okay. This is using linear algebra concept. So x and z. Z is the depth one. Z is basically what you cannot see because it's the axis that is coming out of your eye. Y is tangential to the ground at the device current location and point toward the magnetic north pole. And z points toward the sky and is perpendicular to the ground.
So basically, y is this, z is this.
Right, so you have to multiply the matrix to something in order to get the orientation. Okay, so there we go. By definition, r times gravity is 0, 0, g, and 0, m, 0 as a vector is I times r times geomagnetic north.
Those are the coordinates. 0, 0, is x, y, z, and 0 and 0 is x, y, z.
So x, y, z is the vector product. Okay, let's see.
That's showing, that's how you get the different values inside the matrix.
Right, that's how the matrix is related to your actual coordinate. So the question, the big question is which one do we need, or which one is applicable to our application?
Oh, why?
No, well, okay, these are the sensor types. So you can get all of these sensor types and make use of one or the other. The Android framework does the translation for you, depending on which one you're getting. So let's take a look at this one first, okay? Because this is the first one that is related to what we want to do. Measures the force of gravity in meter per second squared that is applied to a device on all three physical axes. So unless you are accelerating or decelerating, or you're not on Earth, okay, this one is already enough to give you the information that you need, because from this one sensor reading, and you can do your own math to figure out how your device is tilted.
But isn't it always going to be 9.8?
Say again?
Isn't it always going to be 9.8 on Earth?
Well, no, because it's measuring the length of the ray that's pointing toward the ground.
If you're accelerating, if you're in a car and your car is accelerating, it's not going to be the same acceleration, because you have to add to the component of acceleration. So assuming you're not accelerating, you're standing still and you're not moving at all, this is already more than enough for our application. So let's take a look here.
The gravity. Really?
Yep, just gravity. Because gravity returns, okay, the length, okay, so we need to look for the right type here. This is the right one. Okay, so this is measuring, value x, value z, values bracket 0 is acceleration minus gx, or the x component of gravity on the x-axis. And the x-axis is basically, anything to your right-hand side is positive, anything to your left-hand side is negative. So that will give you information about how much rotation you're experiencing. And the values bracket 1 is acceleration minus gy, or the y component, which is vertical down. So that if that is non-zero, that means your device is tilted either this way or that way. And then we have acceleration values bracket z is acceleration minus gz on the z-axis. So that means if you're accelerating, if you're in a car and it is accelerating, that value will be non-zero. But it is not useful to us because, well, would it be useful to us?
If I may, it's always going to be 9.8 as long as it's not free fall. If you're going straight, it's the action of two vectors. One gravity and then another one.
Well, the gravity is going to be 9.8, but depending on how you have the sensor oriented, it's good. The relative components is going to be different.
You can basically you're pulling the value out of how fast it's moving in one direction.
Well, but I mean, gravity is a force, and
right.
It's applied no matter what.
But it's measuring along each different component of your device.
Hold on, though.
And they're combining those. The 9.8 is the combination of all three components together.
No, 9.8 is the one axis force.
But they're assuming that the device is quite flat. What if it's tilted? now you have a component coming out here, a component coming out here, and a component coming out this way. All three of those components together combine to make the 9.8.
That makes sense.
Okay, so gravity sensor is the one that returns a three-dimensional vector. So that means it returns three specific values, indicating the direction and magnitude of gravity. So that means in X, Y, and Z of the device. Okay, so when you look at a device like this one, okay, so I'm drawing a certain device here. So let's say this is the screen, okay? So whatever is to the right-hand side of the screen is positive X. Whatever is to the top of the screen is positive Y. Whatever is pointing toward you is positive Z. So gravity is always the same as pulling down, to the center of the Earth at, a certain, at what? 9.8 meters per second squared, okay? But when you tilt the device, then you can have, okay, when the device is straight like this, then the gravity will only be present with the y-axis. The other two axes should not experience gravity at all. When your device is completely pointing this way, then it will only be the z-axis that is experiencing gravity. When your device is tilted sideways, like this one, then only the x-axis should experience, the full gravity. But if you have any combination of the three rotation, then you'll end up with a component in each axis, depending on how it is rotated, how it is tilted, and so on. So from here, it is already sufficient to calculate the angles that we need to measure, because when you tilt a device like this, then it will have two components. One component will be the y component, the other one will be the x component. If you tilt it like this, tilt it down, just rotate it like this, then some component will be in the z-axis, and some component will be in the y-axis. So when you look at the three, that will give you the information that we need in order to figure out, how to display the lines. But you will have to, if you only use this information, you have to use arc tangent to find out what the angle is supposed to be, because you'll be given the ratio of the triangle. So you have to use arc tangent to find out the angle given the the base and also the height of the triangle. Any questions about this part? The math of just using gravity itself. Yeah.
Not the math, but I want you to scroll back up because there was something that I saw that I thought was pretty interesting. That's right after the beginning explanation of it.
The gyroscope or the acceleration?
That right there. If you read that, it says talking about it sitting on a table and what the accelerometer will reading.
Right.
Or will read rather. But the second sentence is, similarly when the device is in free fall and therefore dangerously accelerating toward the ground. I thought that was funny.
Then the accelerometer reads a magnitude of 0 because it is at 0 g at that point. Right.
Funny and interesting.
So basically the difference is one measures acceleration because it's in meter per second squared, and then the other one is measured in gravity or ratio to gravity, a three-dimensional vector. Oh, units are the same, so it's still it's measured in meter per second squared. So note when the device is at rest, the output of the gravity sensor, which is this one here, should be identical to that of the accelerometer. And our assumption is you'll be using the application pretty much at rest. So you can use either one, but neither will give you the angular interpretation. Okay.
The other thing you need to be aware of is that gravity isn't constant. It depends on where you're at. 9.8 is a sort of defined standard, but it varies over the surface of the globe.
Yeah, but very
maybe, but it may be enough to where we're doing. That makes a difference.
Okay, so here's the rotation vector, which may be a little bit easier to use because things are already expressed in angles. The rotation vector represents the orientation of the device as a combination of an angle and an axis in which the device has rotated through an angle of theta around an axis of x, y, z. The three elements of the rotational vectors are x times sine of theta divided by 2, y times sine of theta divided by 2, and z times sine of theta divided by 2, such as the magnitude of the rotation vector is equal to sine of theta divided by 2, and the direction of the rotation is equal to the direction of the axis of rotation.
Amen.
So that may not be, any easier to use than the, just the gravity one.
Is a accelerometer a subset of the gravity sensor?
An accelerometer works like this. Inside the device itself, it uses, there's a center mass of silicon that is kind of quote-unquote suspended in 3D space. And what happens is, they have one surface here. Basically, it has three surfaces around this center mass, and it is measuring the capacitance between the surfaces. And when this mass is closer to a surface, it changes the capacitance between this mass and that particular surface. And it uses the capacitance change to basically measure how close is this to the center. When everything is at rest, it is at a certain, the capacitance is at a certain constant. But when you try to change it, like under gravity, it will start to change. It will pull the mass either to a particular surface, it will pull it away from a particular surface. So by measuring the capacitance between this mass and a particular surface, you can now know what is the relative position of the mass to that surface. But knowing how it is spring loaded, it can also be used to deduce the amount of acceleration experienced by this mass. But rotation is basically just a translation based on the actual the vectors of the mass.
We got the type orientation.
Type orientation, we have azimuth, which is the angle between magnetic north direction and the y-axis. So magnetic north is basically close enough to the North Star. Okay, so basically what you do, or one way to envision it, is at night you look for the North Star, and then you say, okay, your eye is aligned to the North Star. That is the axis. So it's the angle between the magnetic north and the y-axis of your device. So you look at the North Star, which is a particular line, and then the y-axis of your device, which is the one that is pointing straight up. That's the other axis. So the angle difference between those two is the first value of this particular array. The second value is pitch, which is rotation around the x-axis, with positive values when the x-axis moves toward the y-axis. So the x-axis is the axis of the device pointing to your face, to your eyes. Excuse me, it's the axis of the device pointing straight out of the screen. So if you imagine this is the screen, the x-axis is basically my marker here. That's the x-axis. So this is the difference between is pitch rotation around x-axis. The x-axis is this one, and so the value one is rotation around x-axis. So it's basically this part here. Okay, and then the last value is rho, which is around rotation around the x-axis, increasing as the device moves clockwise. So that would be, I think the terminology they use is not exactly correct. But because when you say rotation around an axis, it is like this. But this one is actually more like that. It's the rotation around the z-axis in this case. That's rho. Well, we can write an app to test it. Yep, we can do it now.
Is there any other information we should go over first?
Say again?
Is there any other information we should go over first?
Well, I don't think so. I mean, that should be it. Because with these three values, you can translate these values into what we need to do for the homework assignment. I'm pretty sure you can select one of the multiple sensors and still get the same amount of information. It's just that these are basically translated values to begin with. All right, so let's go ahead and write an app, to quickly identify what we're reading back with a particular sensor. In a way, I kind of enjoy this part of the job. I get to write programs. And what is the name? Test orientation. Test orientation.
You get to write clean programs that 5 other people aren't maintaining at the same time and destroying your code. That's just the honest answer there.
Okay, so I want to limit the Android API to a certain level. What is the lowest API level that you guys can deal with? Because it depends on what devices you have for testing purposes.
4.3.
4.3.
2.2.
2.2. Okay, that's fine. So we'll use Froyo as the.
You don't have to. I mean, it's fine.
No, but I have to test the program too.
So 4.3 for me. I guess I have my tablets.
Okay.
Right,
I have a tablet that like a camera doesn't work. It's like using experimental setting.
I would update to 4.4, but so far there's no root method yet. Or
You have a
Verizon.
Samsung. I'm sorry, you have a Samsung.
Buy a Galaxy S5.
Well, Samsung is nice. I have a Samsung too, but in terms of getting CyanogenMod to run on those things, sometimes it works, sometimes it don't. Because Samsung is not particularly the most. They're not necessarily the most open company when it comes to opening up their ROMs and whatnot.
Verizon locked the bootloader, or forced Samsung to lock the bootloader.
Whatever.
It's only Verizon.
What?
It's only Verizon.
Not limited to Verizon, but it's the carriers that are forcing Samsung to lock the bootloader. If it was up to Samsung, they would just leave it unlocked, but they have a contract, so.
Jelly bean. No, that's Kit Kat. Jelly bean. Yeah, but what phone do you have? What? Galaxy S4 or 5?
Can I make it blank? Nope.
Yeah, but he's talking about moving and stuff. I like my Asus devices, they're really easy to read. I need to find a new digitizer and screen for one broke.
Okay, so now I got three text views here, and I'm just going to change the names of the text views so that I can easily identify which one is which. This is value 1, which is basically values bracket 1. And then the last one is text view bracket 3. Value 2. It's the last item. All right, so now we have 3 text views. I just blanked them to begin with because they don't really have any particular value to display until I have the sensor up and running. So now we can go to my source code, because I'm not going to display anything graphical with this one. I just want to display the actual values. So we want to go here and go to fragment holder, because this is where I can do the initialization. Well, let's see. Yep, with this one I can start with on create. All right, so the first thing I need to do is to find out what sensors I have, and also keep a note of the sensor itself. So we have to use a private field or private member. It is a sensor, and I'll just call that my orientation sensor. Input sensor. So, and in the onCreate method, we'll go ahead and allocate that for that sensor. So we'll say orientation sensor is sensor dot
type orientation.
No. But I have to get the sensor. Oh, I forgot. That's
oh yeah.
So I'm gonna plagiarize my own code. And look for mentioning of sensor. Okay, we have to get the sensor manager first, and then from the sensor manager we can do the rest. Okay, so I have to plagiarize. I know it doesn't really count as plagiarize if it's my own code.
Plagiarize yourself.
Yes. So sensor manager is a type that I also need to import. So now that I have a sensor manager, I can ask the sensor manager to give me a default sensor. Get default sensor. And select sensor dot orientation, right?
Yeah.
There we go. Oh, it's deprecated. Sorry?
Why is the type?
Why is it struck out?
Yeah.
Because it's deprecated.
Oh.
It still works. It's just
It still
ideally
works,
you
it's
should
just
use
not,
something else.
yeah,
There
they
was-
don't want us to do that.
It was saying on the, when you had the documentation pulled up to use something else.
So get orientation instead.
But that had extra parameters and stuff.
Well, that requires R to be passed to it first. So when it returns, the array is filled with the resulting value. We have rotation around the z-axis, y-axis, and x-axis and y-axis. The reference coordinate system is different from the world coordinate system defined for the rotation matrix, which is R. X is defined as the vector product x, y, z is tangential to the ground at the device current location and roughly points west. X is defined as the vector product y, z is tangential to the ground.
I think that's how you get the rotation.
But what do I use to pass to it? Yeah, what is R? It's get rotation matrix. Remember we looked into this already?
Yeah.
Computes the inclination matrix I as well as the rotation matrix R, transforming a vector from the device coordinate system to the world's coordination system. It has four parameters, 4 arrays.
Are they optional?
Hmm?
Is that type of information optional?
In order for the
Okay, right
rotation.
here, parameter. R is an array of 9 floats holding the rotation matrix R. When this function returns, R can be null, I can be null. Gravity is an array of 3 floats containing the gravity vector expressed in the device's coordinate. You can simply use the values returned by a sensor event of a sensor type of accelerometer. So that means we can use this to create this particular matrix. Geomagnetic is an array of 3 floats containing the geomagnetic vector expressed in the device coordinate. You can simply use the values returned by a sensor event of a sensor of type magnetic field, but it cannot be null. So it does depend on both gravity and geomagnetic. Returns true on success, false on failure.
So in other words, you have to have an accelerometer and the magnetic field sensors in order to do this.
Well, it is not clear yet, which one is being returned. I'm assuming R is returned and I is returned as well. And R is the one that we need in order to send it to the other subroutine, to the other method. I'm just going to use the deprecated, sensor type for now, and just to see what it is returning. Okay, so now that we have sensor orientation sensor initialized, the next thing we need to do is to say, okay, what do we want it to do when the sensor reports something back? So now we need to set up the on sensor change, I think, event. So I'm just going to borrow that code again. 26 of them. There's a way to close all except for one, right? Close others. All right, so now we only have this one on, and we'll need test sensors, also. So we'll have both of these on. Let's see. So we want to set up. On sensor changed. So it's basically a method that has to fit a particular interface. So that's what we need to do, is to set up main activity to also implement sensor event listener. That's what we need to do. So we go back here and say this one implements sensor, and remember the name, sensor event listener. Okay, it's better just to copy and paste it. There we go. All right, so doing this will automatically prompt an error to basically say we have to implement unimplemented methods, so we just add it automatically. So on sensor accuracy change, we are not going to do anything, but on sensor value change, we do want to do something here. So what we want to do is to reflect the, so we want to say if event dot, we want to look at the sensor type first. So we want to say if event sensor equals to our sensor is just a sensor. Okay, so we should be able to do this. We're just complaining.
Are you missing?
Let's finish the other part first.
Yeah.
Orientation sensor. There we go. So if it is the orientation sensor, then we want to reflect the reading on the screen. So we want to basically say,
XU0 gives.
yeah, but we're inside the activity, so we can't really get to that part easily. Okay. So we have to say private text view. TV0, TV1, and TV2, and we'll get those initialized.
You have to import it.
Yeah, it just wants to import it.
Click on the left. The little icon over there.
Import text view. I thought I just clicked.
Double click.
Inside here, I need to use root view to find all the other stuff. So I would say TV1 is text view, and then we use root view dot find view by ID, r dot ID dot text view value 0. TV0, colon, and it's a static class, so it cannot access it. So we need to do a cast to main activity get activity dot tv0 container.
Looks like you have one extra parenthesis there.
Nope, I do not.
Oh, okay.
This is supposed to be a cast. Did I mistype main activity? Main activity. No, it's not a typo. Cannot be resolved, nor is a field. Main activity is the name of the class.
And minimize the package explorer so we can see the rest of the screen.
Say again?
Minimize the package explorer.
Main activity cannot be resolved to a variable.
Try saving and see if it fixes it.
Say again?
Try saving and see if it fixes it.
I don't think so. Because I'm trying to cast the get activity result into a main activity. Oh, you know what? I know what. That works.
Yeah.
Because I'm casting a view, I'm casting the wrong thing. It has to do with the operator precedence. Okay, so we just.
I said that and you ignored me.
You said there were extra parentheses.
There was at the beginning.
But it's
Get
not
activity.
extra, it is nested incorrectly. There we go. Okay, so now we have the text views instantiated here. So as a method down here on sensor value, on sensor change, I have access to TV0, 1, and 2. So now I can say TV0 set text to event dot values bracket 0 dot. Oh, okay, I think what to do. It is a float dot to string with parentheses, close extra parentheses. Okay, missing one parenthesis here. Okay. Aren't you guys starting to miss App Inventor?
Nope.
No. Okay, that should do it. It returns a void, so I don't have to specify a boolean to return. So that should do it.
Are you going to put a restriction on the length of the string?
Hmm?
Do you want to put a restriction on the length of the string?
No, I don't. I don't need to, because a text view can display width of or length of any length. So, okay, it's still complaining about something. So let me save all the files first.
There you go.
Now it doesn't complain about anything.
What is the precision on floats in Android?
Huh?
What is the precision on floats in Android? Is it just
Well, float is float.
Yeah.
It's always a 32-bit number, and the mantissa, which is the part that controls the precision, only has about 20, 21, 22 bits. So it's not really that good. I mean, it suffices, but yep.
And for the text view, should we put it as Phil Paris, so it's trusted and stuff?
Oh, okay, yeah.
What do you say?
Field parents.
Put it as.
What is the actual size of the text? So let's go to resource.
In other words, keep it from flowing off the screen?
No, it's whether it is going to be truncated or not. I think that's the question. Oh, the wrong app.
I think it's just going to wrap.
Oh, I see, because with floating point it can continue on. Okay, so with this one, the layout is, there's no particular layout. Okay. Layout width is wrap content.
match parent is probably what you
No,
mean.
wrap content is fine because when the text width changes, wrap content will make the text view as wide as it needs. So I think that this is appropriate. All right, so we are
Let's test it.
ready to go. And I need to attach my mobile device first. And I don't have the cable to do it.
Oh, you got a cable?
I don't have
Okay.
one with me.
You don't have one?
I don't have one with me. I think
Okay.
Tristan does though.
Okay. I'll just borrow it for now. Thank you.
For the drawing, you have to use invalidate, huh?
If you want to draw it right away, you have to do an invalidate. But if you just leave it the way it is, it will get updated. It's just not like right away.
Oh, okay, so it probably more efficient not to invalidate everything.
Right. Yeah, if you invalidate, it's what invalidate does is it will basically invalidate the entire view. So depending on where you call invalidate, it'll basically say redraw everything.
Oh, okay, yeah.
Whereas in this case, I'm only setting the text of one text view, so it will do it when it gets around to do it. All right, so I need to set a permission to allow. And I need to display it too. That part. Okay, it is running, but it's not displaying anything. So maybe it is because the views are not set up. The width is not set up correctly. Change that. It's still displaying blank. I'm gonna show you guys what I'm seeing, which at this point is not too exciting.
Do we need threading to do this properly?
No, we don't.
You can set a breakpoint and see what values it's returning. Set a breakpoint and see what values it is returning.
Yeah, we can certainly do that too. So let's. But I'm just kind of bummed that it's not working.
Tag is sad.
Okay, so well, to do the debugging, the first thing I would do is to put a breakpoint here. Because I want to make sure that I even get into this part. So let's go ahead and debug test orientation. And we are we at the breakpoint?
I don't see it.
Nope. Okay, I'm forgetting to do something, I think. I'm forgetting to activate the sensor because I got it. I just haven't turned it on yet. Minor details.
Turning the sensor on so I can use it.
Yeah, it's like, yeah. Okay, so let's see. Okay, on sensor changed.
Register the sensor.
Yeah, we have to register the
Sensor manager, register listener. Oh.
register listener, and it's going to be this. Okay, there we go. Because otherwise, it's changing, but I never said that I'm interested in the changes.
It's like, yes, you're changing. So
I think the Eclipse's compiler should come up with like, so you said you wanted to use this, but you're not actually using it.
Okay, so we want to register listener, and we want to specify a listener and for this particular sensor. So there are several ways to do it. Sensor, event listener, sensor listener. Several are deprecated. And they all will require the rate in microseconds, which is fine. The listener is going to be this because I'm implementing that particular interface. The sensor is my orientation sensor, and then this is how fast it should update it, and it's under sensor dot. And there are two constants for this, if I remember right. It's under sensor manager class, not under sensor.
So it's a delay normal.
So it's under sensor manager dot. We want to use delay normal. There we go. Save all. Disconnect. And it's complaining that I'm missing a semicolon. It's good. I think that's it. I mean, I'm just gonna run it. Yep, it certainly is working. I'll show you guys what I'm seeing.
Sure, they're not that big.
There we go. Yeah, so I'm holding it up pretty much straight up right now, and if I rotate it like this, you can see the first number changes. So that's basically magnetic north. The first number.
Mm-hmm.
Yeah.
Why does it lay it down?
Yeah, it's okay. If I do a pitch, it's the second number that is changed, and I'm holding it back up. See, the second number is corresponding to pitch, so the third number corresponds to roll, like this.
There it goes.
Oh, screensaver. Okay, so now it's it's the roll. It's 17 degrees rolled, and then 0 degrees again, close to 0, and then roll the other way.
What's with all your messages? 119, 54, 28.
Yeah. Ignored. And if I do it like this, it's the second number that is changed because it is the pitch.
Which sensor? Is this still the gravity sensor that you're using?
Orientation, which is deprecated. It's deprecated, but in order to do the same thing, I would have to go through the trouble of using the two methods. I have to use one method to populate the matrix R, and then use R in order to use the other one.
We could see how level the room is.
Well, that's assuming this device is actually calibrated, because if I put it flat on a surface,
then the first number should go up.
It's go to sleep again. The first number is the first number is not the interesting one. Yeah, it is pretty calibrated. It's mostly 0. Because remember, the second number corresponds to pitch. Yeah.
Well, so in that case, though, then the second and third number should both be 0 if it's laying flat.
I'm not sure about the third number, because the third number has no definition when it's flat. Because if I rotate it like this, the third number really has no real definition when it's flat like this. I mean, it's not defined, because the third number is basically asking how much roll are we experiencing. So when you're flat like this, it doesn't make any sense. There's no roll to speak of.
The room is fairly level.
Well, the device is fairly calibrated. It's not 0 only because there's a little protrusion because of the camera protection thing.
And plus, whatever it's sitting on may not be flat as well.
Well, in the case of a PC, it has to be calibrated, right? I mean,
yeah, you have to have a flat surface to begin
Someone
with.
busted out their calipers at the factory on it.
Try to put it on the screen.
Say again?
on the screen, like the other way?
Oh, the other way around? Yeah, that works too.
So that's positive.
Yeah, that's 180. So it's pretty close. It has, a fraction of a degree of difference. Actually, if you really want to see whether it's truly calibrated, you do it once like this, and then you turn it, 180 degrees, and then do it again, so to see, whether it is really just, orientation change.
Well, I know there's a option to calibrate it.
Yeah, there is an option. You can also, in your own application, you can do your own calibration too. You can store your own calibration constants. So in this case, it should be, so it's the device itself that is not aligned, because if it is the table that is not aligned, then this number should be 180.5 or so, because it's the other part of it. But if it is reporting exactly the same number, that means the table itself is aligned. It's the device that is, the sensor itself is not properly calibrated by half a degree.
I also hear that for most phones, the precision of the sensor is not that great. Plus, it has a bunch of noise.
It's good enough for most applications. Yeah. I mean, it depends on what you want to use it for.
I mean, if you're trying to use it to navigate, you would use something else. But
well, okay, how are you going to mount it to something that needs, orientation, sensing? That is the first question, right? Because the mount itself, has, imprecision built into it. So, half a degree is pretty good. I mean, I would say it's pretty good. As far as your application is concerned, you have the numbers already, to work with in this case, because you have the, all the angles already reported this way. So this is one way to do it. It's deprecated. You probably want to look into how to do it without using the deprecated feature, which is to use the method calls that we were talking about earlier.
Get rotation.
Yeah, you have to work with get rotation matrix first, and then the result of this, which is the R matrix. When you look at the R matrix, this is an array of 9 floats holding the rotation matrix R when this function returns. So R can be passed in return to get orientation. So get orientation is going to take R. Okay, let's look at the full specification here. It returns an array value passed. It returns the array values passed as argument. In other words, it just returns back values. So you pass it values, it returns back in the values. But you have to supply R. R is the one thing that it needs in order to do the calculation.
And what would you get values from?
R is the result of using get rotation matrix.
No, I mean the values parameter.
You create a matrix. You just create an array to hold the values.
An array of 3 floats to hold the result.
Yeah, so you have to allocate the storage for the array. In Java, I think it's just new float in angle brackets, the number of elements. So you allocate an array like that. But you have to call get rotation matrix to get R. And that one, you can pass null as I if we're not storing that. But gravity and geomagnetic, are basically values coming back from the compass, and also coming back from the gravity sensor. So that means if you want to use get rotation matrix or get rotation, you will have to do your own interpretation based on the other 2 sensors, whereas get orient, whereas the current method is only using quote unquote 1 sensor. It's basically integrating those 2 information into one, or 2 types of information into one. So I'm not quite sure why they deprecate type orientation, because it is really quite handy.
It's a lot easier too.
Well, it is easier, and but I think the reason why they want to separate it back into or the reason why they want to use get orientation is not to merge the 2 sensors into one, and as a result, you will have the opportunity to inject values into the matrix that is needed by get orientation. So that way you can do other things. In other words, if we use get orientation, it doesn't get orientation as a call itself does not tie in to any particular sensor. You can have a file of values that you have collected earlier, and you just have to feed it, R, which you can compute using the other values, and so you can do all kinds of other stuff, with this. It's just more orthogonal. It's not tied into the sensor itself anymore. Okay, I'll explain it slightly differently. You look at this method here. Does it tie itself into any particular sensor? Does it require a particular sensor to work? Nope. There's no implication, right? I mean, because the value that it does require, which is the matrix R, can come from a file. It can be generated by an application. It can be generated by a subroutine, a method. Yep.
Well, the old method doesn't link itself to other things. It's just the.
But it does tie itself to the availability of the two sensors. Okay. This method does not. This method is basically just saying, give me the give me the matrix R. I will give you the orientation as a result.
I forgot.
But who is supplying R? Well, it can be coming from the other call. It can also be coming from a file. It can be a log. You can test it by using fixed values, right? But the old method, deprecated method, does require the use of 1, the gravity sensor, and 2, the compass.
Make R come from the accelerometer.
Right. So the other call here, which is get rotation matrix, also does not depend on a particular sensor. So even though in the description here, if you look all the way down here, it describes gravity, which is one of the input into this particular method, can be the free floats coming back from a accelerometer, sensor, but it doesn't have to be. In other words, I can give you a file with a whole bunch of values, for gravity, and another bunch of values representing magnetic field, and then you don't need a single sensor in order to compute the orientation and also the rotation matrix. So that's why I think they deprecated the orientation sensor, because it's just not a clean way of doing things, and this is a lot cleaner from the perspective of we only have to do what is necessary, whereas the other one is doing something internal to the Android framework to combine the output of two sensors into one single output, but it's not an actual sensor. It's not an actual sensor. It's the combination of two sensors.
So the get rotation matrix would be the ideal, is it?
Right. Even though it is slightly more involved, because now you need to have two listeners. One listener to deal with the gravity sensor, and basically have your own place to store the values, and then another listener to deal with the geomagnetic sensor, which is basically your compass. So combining, so you have your own float arrays to store the feedback from gravity and also the feedback from geomagnetic sensor, and then you have to make your call to this particular method so that you can compute the matrix R. So you can compute R from get rotation matrix. Once you have R, then you can come back here and call get orientation, and then the resulting orientation will still be the same as what we saw with my app here. So you will still in return in the end you still get the same result, but you will have to write two sensor listeners, because in this case there's one sensor to only deal with the accelerometer, and then the other one to deal with the compass, and then you have to combine the values of the two using your own code, but using a method that is already supplied by which class is this? Sensor manager class. So you can do it either way. I mean, this is kind of like a shorthanded way to do it, but it works.
And you said you're going to share the code?
Yeah, I'll share the code. So let me. So are there any other questions? I think this this is the last piece that we really need for the homework assignment. So once we have the angle, you can use. So we have the angle, and then we have the height of the display. So you need tangent to compute the values, like the actual vertices of the line. Is that making any sense? Okay. Is that again? Once we have the angle, because this particular sample program returns the angles, right? So once you have the angle in degrees, then you have to convert into radian first, because I think sine, cosine, and tangent only take measurement of angle in radians, but not in degrees. You can double check. I mean, that's a Java thing. It's not an Android thing. But once you have that, then you can compute. Okay, so what we are dealing with here is this. Okay, so with your display, you will have to kind of imagine there's a center line here. So the first thing you have to do is to determine where is the intersection of the horizon and also the vertical line, the plumb line. Okay, so let's say we determine it is here, and that is only determined by the horizon itself. So the horizon can be tilted a little bit, because if you roll your display this way, the horizon will be displayed this way. And then the vertical line or the plumb line will be displayed kind of like this one here. So in order to come up with this line, you have to know the degree here. So let's say this is theta. So knowing theta and knowing the width of the display, you can now compute this particular height here, and also the displacement from the center of the display to this vertex depends on the pitch of your device. So does everybody know how to do this part here? How to compute where to put your intersection?
Can we go over it?
I think we went over a little bit of that. Okay, so this device is slightly pitched down a little bit, right? And so what you need to do is to find out what is the angle. This angle is important. And then the second thing you need to do is to find out what is the camera view, coverage angle. That is important because you need to map. Okay, let me try to see how I display this. Okay. When you look at the display, you are projecting what the camera is seeing into a two-dimensional plane, right? This angle is already known because you can get parameters of a camera in order to find out what is the coverage view angle coverage of your camera in a particular axis. It will separate it into horizontal and also vertical. So once you have this, when your camera is pointing straight, at the horizon, then there's no displacement. In other words, you'll be displaying the horizon right in the middle of the display. When your camera is tilted up at this angle, you'll be at one edge. So you will be barely seeing the horizon either on the top or at the bottom. And in between, you have to figure out how to draw that horizon. Is that making any sense? So kind of imagine this thing here being tilted a little bit, okay, like that. And your camera is still viewing it like this. But the horizon is now going out like that. So what you need to do is to find out where is it intersecting with the 2D screen when your center is over here. So in this orientation, this angle is the pitch angle. So when your device is pointing down a little bit, that pitch angle is this angle here. So from the center of your entire display, the number of pixels you have to go up to this to determine the center point of your intersection is basically, let's see how I'm gonna do this. It will be this distance here. This is D, and that's theta. So this would be, so H is D times, I think that's tangent, right? Yeah, the tangent of theta. Is that making any sense? More or less? How do we get D?
The angle below it.
Hmm?
Talking about the angle on the other side of theta.
Okay, so let's say this is not theta. What is another? I would just call this
Gamma.
angle A.
Yeah, that works.
Angle A. Okay, that's A. Okay, so if this is angle A and you are choosing to use this many pixels, so let's call this P number of pixels. Then you can determine what is D, because this is basically D here, right? So D is, let's see.
Sinus alpha is P on P. Sinus is P divided B. Oh, no, that's tangent.
That's tangent, yeah.
Tangent.
So we have, tangent is P divided by D is the tangent of alpha. So D itself is going to be P, which is the number of pixels from the center of your screen to the top edge of your screen, divided by the tangent of alpha. And alpha is something that is returned by get parameters of your camera. So those are the math that you have to kind of go through.
Whoever thought would use trigonometry
Huh?
ever again.
I'll probably give you guys a note to about all this stuff here, the math.
Trig is useful.
Oh, trig is certainly useful for a lot of different purposes. Are we still doing okay? All right. Now this is assuming your device does not have a zoom lens, because if you have a zoom lens, then you have to dynamically determine this, because the view angle, alpha, depends on the zoom level. So every time you zoom, you have to recalculate, these values. Basically, D is changing depending on the alpha angle. But most devices do not have a zoom lens. Does anyone have a zoom lens on your phone, or you do? Okay, so in your case, you can set up a listener, with a camera, you can set up a listener for the zoom level change. So then you can use, zoom level change and basically say, okay, once the zoom level change, I believe, get parameters of the camera will reflect the actual focal length at that time. So you will have to recompute D in order to determine, how to compute the intersection of the point on your screen. Yep.
Is that physical zoom or is that digital zoom?
It's it's physical zoom.
Oh, okay.
Yep. I think digital zoom is not supported natively by the Android framework.
Oh, really?
Let's take a look. I don't know, because I don't really
Digital
use that.
zoom would have to be. Because of how it takes photos, it goes through its own framework to capture the file and
So does the file
encode it.
Oh, okay. So it actually reports the fake focal length as if it is a real zoom.
Yeah, because because the framework is what actually records the image and saves it to a file path
Okay.
provided.
Okay. But the preview, does the preview tie into the digital zoom, or by default is it off? How do you zoom with your camera when you have an optical zoom?
Either pinch or zoom or use the volume rocker.
Okay.
I think most
When you-
phones probably don't have the physical zoom, right?
Or-
Maybe I'm just
A
really
lot
or
of phones
digital
don't,
zoom.
but they're starting to appear more often in the higher end type of devices. Mine does not have mine doesn't have an optical zoom.
Yeah, that's digital zoom I was referring to.
Yep.
Yeah.
So the framework probably treats both the same way, whether it's physical or not. You still have to, but you're still gonna get the parameters through the camera. Get parameters call. The only question is, do you want to make it sensitive to the zoom level? Yep.
Well, for physical zoom though, it would just have to change the focal.
Right, but when you
Right.
change the focal length, you're changing this, alpha here. When you change the alpha, it changes the way you calculate the intercept of, where the horizon is going to intersect with the center line.
I thought digital zoom though was just
Blowing up pixels, right?
Yeah, blowing up the pixels and then re-aliasing them so that.
Right, so it looks smooth instead of a big pixel like this.
So it probably
now
does
it
treat
looks
them. I would think it would treat them differently then.
No, not in this case. I
Maybe
mean,
at the lowest level,
For the purpose
probably
of
not.
calculating, the view angle and stuff like that, it should not. make any difference.
Not bad.
So define P. Are you just like counting the pixels? Like does it give you like
Right.
a get parameter? So it will give you like the total
It's
amount
in
of pixels?
it's in whatever units you want to use with your canvas.
Okay.
So if your canvas is calculating in virtual pixels, which is the default, then that P, has to be in that, everything is going to be in that unit.
How do you do it if it's like if you're trying to do it relative though? When it's
Relative to?
like relative to the screen size, like wouldn't it vary quite a bit?
You can make your preview window, fit in a frame. So by controlling the size of the frame, you can control the actual preview size in terms of number of pixels.
There's no parameter. Oh, sorry.
Can you just get the pixel size of the screen and use that instead? Because you can do that. You can get the screen resolution.
You can get the screen resolution. You can also, if you look at the preview of a camera, let me just take a look at preview.
Yeah, but the problem with that though is that usually the camera picture resolution is higher than the phone itself.
Right, way
higher.
The camera is way higher than what you can display on screen most of the time.
But usually it is the same aspect ratio of the camera.
Right.
At least in widescreen.
Well,
in my case, it's not. It's slightly distorted if I use the entire screen.
Well, what's 8 megapixels? It's
8 megapixels is more than 1080p.
Yeah, that's actually like 1400p.
And this is like 16 megapixel.
Yeah, that's actually approaching 4K. I actually have a camera that takes pictures in 4K. It's pretty awesome. The T3i takes pictures in 4K resolution.
Oh yeah, so this is 13 megapixel, 4000 or 4128
by what?
By 3069. That's 96.
So that's actually higher than 4K. Because 2160 is 4K resolution. Yeah. Why are they calling it 16 by 9 now?
I think a lot of times though, when you have like super high megapixels on a phone, a lot of times it's by like what's it called, like
because of
like
this
kind of like
is this is a full sensor, and this is just cropping the top and bottom.
Just to say that they have like something.
Yeah, I mean this is essentially what 4K is. Like my camera at home takes it.
Okay, so are there any questions about this part? No.
I think we'll have a lot more once we get started.
Yeah, once we get started, and that's what
if Tack ever checks his damn email.
yeah. But that's why I have physical office hour here, so you don't have to send me email. You can just come to my office, wake me up, and then ask questions.
So, can we talk about other stuff now? I want to decompress from final stuff. I've got a final in calculus tomorrow.
I mean, are there any other questions related to the final project? I mean,
Guess not.
no.
So we have
How do you make the line move?
How do you make the line move?
Yeah.
Okay. When the line moves, there are several aspects of making the quote unquote making the line move. The first thing is, once you draw something on a canvas, when you draw something else, that something else is added on top of what you have drawn earlier. So there's no way to quote unquote move a line when you are using a canvas. So what you need to do is you erase the previous quote unquote screen first, which is basically a canvas in a view, and then you draw new lines to
Basically
replace the old line.
Basically doing the animation.
Right, but you have to know how to do the erasing. The note in the assignment already contains a link to basically tell you how to erase what is already inside the canvas. Is to basically paint the entire canvas with a transparent paint, and then after that you can draw the new one. So is your question that related to that,
Yeah,
or
basically to that cross thing, like it has to move at some point, right?
it has to move because every time your orientation sensor comes back with an update, that has to change. So
But what is that object?
what is that object?
The line. What object?
You have to draw the line using the draw line method of a canvas.
And it only draw to your screen.
Hmm?
It only draw to your screen, like how big your screen is. Or
Would you want us to put like a filter on it so it removes like the jitter?
No, it can jitter a little bit. There's no need for actual smoothing. But when you go to the app called Test Draw, and I'll have to make sure that I distribute this code to all of you, and you go to Text View, inside text view, we have the on-draw method. The on-draw method depends on the canvas. So what you need to do is to invalidate the view itself to basically force the on-draw method to be called by the system. When the on-draw method is called, then you can use the canvas method, like draw circle. In this case it's draw circle, but you can also use C dot draw a whole bunch of stuff, including draw path, and also draw points, draw rectangle, and so on. Yeah, and there's draw line and draw lines. What you really want is just draw a line, one single line for the horizon and one single line for the plumb line, because lines, is drawing a polygon, and you don't want to draw a polygon. You want to draw two independent lines.
So they're not fixed. As soon as you run the application, they're there. You have to actually draw.
Yeah, they have to be updated because when your sensor comes back, it will trigger the redrawing of the lines. So that's why you have to set up the sensor event listener, so that that triggers everything. Okay, once you set up everything, the sensor event listener, the on sensor change event will trigger everything, because when that changes, you have to recompute all the new coordinates of how to draw the lines, and then you trigger you call the invalidate method of the view that contains the canvas, and then inside the on-draw method of that particular view, you specify how to redraw the screen. Basically, so you have to communicate the orientation numbers to the view so that the view knows how to redraw the other stuff.
I thought you said we didn't need the invalidate because that would erase the entire view, right?
No, you need the invalidate to trigger on draw to draw again. Yeah. So in this case, you do need that because you need to trigger the operation. Yep.
We haven't gone over like a 3D environment.
No, we have not. I think that opens up a whole new can of worms. So. Yep. Well, not only that, but 3D is rendered usually by representation of object in 3D space first. So you have to control the light source, you have to control where the objects are, what surface or what texture you're wrapping with the objects, and so on. And then the 3D engine will do the rendering by itself. So you have to basically control where you are, what is your view angle, what is your orientation, where are the objects, what are the light sources, what is the surface type of each object. And then after you set up everything, then you just say, draw. And it will draw inside a particular view, which is basically a portal, because it is not your main thread actually doing the rendering anymore. So the rendering is done by the framework itself, which most likely is going to use a graphics engine, because some mobile devices do have graphics engines. Yeah, so that will handle the actual rendering. So it's not your main thread that is actually doing the rendering. It's something else going to render, but it will display through your activity onto the screen.
Well, like in that, if you're using, like if your device uses a Tegra processor, then it'll use the last two cores to do the rendering instead of the first two.
They use a few for just the management of the other ones?
Yeah.
Yep.
For all the graphics compute units.
Thank you.
Well,
So,
I think it's maybe just the last core that does it.
well, it is not as useful right now because most mobile apps, like Android mobile apps, do not use 3D rendering, because the availability of the graphics engine is not commonplace yet with most of the devices.
2 or 3 processors.
Yeah, so if you don't have if you don't have the extra processing power and you're doing 3D rendering the whole time, you're gonna chew up your battery like there's no tomorrow, and the performance is going to suffer as well.
My tablet has the ability to do 4x MSAA, and it sucks battery when I'm using it. Like I turned it on doing development one time and just unplugged it just to see, and the battery just every 10 minutes was like losing 5%.
Right, but think about what type of computation it has to go through to do 3D rendering, because 3D rendering is not like 2D rendering. 2D rendering is just painting pixels, and it's fairly straightforward. How to draw a circle. I mean, there are really fast methods of drawing circles.
When you only have to alias the one surface as well.
Right, but even the aliasing part is fairly easy to do. You can use integer math only, in those cases. Now, when it comes to 3D rendering, what most programs do, or what most graphics engines do, is they use ray tracing. In other words, imagine that you have a screen in front of you, okay, like a real mesh type of screen, and you're basically asking, if I see through this one hole in the mesh, okay, what is that one point, or what is that one ray, or one point going? What is it going to intercept first? Okay, is there an object it's going to intercept? If it does intercept with one particular object, then you have to say, okay, which component of the surface, and is this line intercepting with that object? If you're intercepting with a matte object that does not reflect, that is not a mirror, you're lucky, because at that point it will basically look at all the light sources and figure out what is the intensity of that pixel.
It uses OpenGL.
Yeah.
But does it do ray tracing?
Almost every 3D rendering program use a variation of ray tracing mechanism or another.
So I don't think it would handle mirror system. You have to manually do something like that.
But you will still be going through each and every single pixel looking out.
Yeah.
Yeah.
But ray tracing, like we were talking about,
it will bounce. Yep.
And OpenGL doesn't do that. You have to.
It doesn't have mirror surface. Okay, but you still have to combine the light sources. So you still end up with a lot of computation, because there's a lot of sign and code.
Is also the transformations too.
Yep, because the orientation of the surface relative to the light sources.
And it's also two different varieties of OpenGL now for the Android. You got the older version, which is what the original OpenGL was, and the later version, which is using fragment shaders. And they're very different in how to do it.
Okay.
I'm familiar with the first version, I'm not so much with the second.
Okay. Well, the best person to ask around here about OpenGL is Professor Fox. Yeah, that's his. I think that's his thesis. Yeah, his master's thesis was on some sort of 3D rendering.
He chopped off a cube and turned it into a sphere.
Yeah, I did ray tracing, way back in, when I took a computer graphics class.
Yeah, because
but it's still a lot of heavy-duty computation. That's why 3D rendering is it takes a lot of processing resources, and it's not well supported by most mobile devices yet.
Well, even on a computer, or in some of my computer, I've been doing just dabbling in 3D rendering, and I can wait a good amount of time for a single scene to render.
Well, that's with all the special effects like mirror, like surfaces, reflection.
Even just simple, and even letting it run on my a bit old now, but 8800 GTX.
Yep, and that's why on mobile devices, it's not going to be realistic for a while, but at some point it will be realistic to assume that you can do 3D rendering with a mobile device. It's just like we never had like multi-core processors on mobile devices, and like 5 years ago I think they do not exist yet, and yet these days you pick up almost any mobile device and it's either dual core or quad core, right? I mean, you cannot find a single core mobile device anymore.
Actually, Android, when it first, not Android, yeah, it was Android. The Snapdragon processor was the first dual-core processor for mobile, and that was 5 years ago, and it just came out, so it wasn't even available yet.
Yes, but these days you go to any store to buy a a device, it's probably at least dual core.
Yeah, and it's not even like it's a dual.
They don't advertise it anymore. It's like, oh, we have multi-core.
It's not like it's a dual core like 600 megahertz processor either. It's a dual core like 1.3 gigahertz processor. It's insane.
Yep. Well, but it is a RISC processor, so it doesn't really quite do the same amount of work per clock compared to a Pentium processor. But it doesn't suck battery the same way either. Yep. Okay.
So you were curious about the iPhone's 5S's sensor?
The fingerprint sensor. So how does it work?
So
do you just press on it, or do
you
you
have to
need
set
to
up a
scan it?
passcode,
Oh,
and,
okay.
then you register your fingerprints, and then after you register your fingerprint, you just touch it.
Mm-hmm. Oh.
It would have to have a passcode. If something happens to your finger that is registered, then you're locked out.
If something happens to your finger.
Yeah, you can actually turn off the simple passcode too for 5S.
You can do facial, and also fingerprint.
But
DNA testing.
Basically,
Retina.
once you have it unlocked, you go inside a Touch ID, hit fingerprint, and then you place your finger on here, and it'll vibrate every time you need to move your finger.
Okay.
And then you just got to move your finger around.
Okay, so it's basically a 2D sensor because it reads your entire fingerprint without any swipe motion.
Right. And then, so basically, it reads your entire fingerprint. Like, that's why I'm moving my finger around, because it has to get the whole thing.
Yeah.
And then, once it completes that part.
Because each time you press onto the sensor, some ridges register and some ridges do not register.
Well, and also, if you put the same ridges down at the multiple times, it will tell you, no, don't do that, and it'll fail the registration process of the fingerprint. So it actually is fairly advanced.
Well, this is the infancy stage, of this type of technology, because I think eventually they can make this sensor apply to the entire sensor area, like the entire screen. Now that would be interesting because now they can tell not only that you're touching it, but they also know which finger you're using to touch the screen. So now you can do multi-finger gesture, and some depend on your thumb and your index finger, and some will depend on the other two fingers or the other finger combinations.
You can register cat paws to this.
You can register what?
A cat paw.
So only your cat can unlock it.
You know which cat too. Yeah, for certain cats it will just activate a BB gun.
Like anything that has a definition to it can be registered.
Yeah. So now I've registered my new fingerprint. Okay, and so now I can use it to unlock.
Yeah, I think the way it works is behind the sensor is a camera.
Actually, I've seen it taken apart. It's
at an angle, right?
A lens, and then a camera,
and
then
an angle.
A ring at an angle, or the camera's at an angle, and then there's actually a capacitance sensor on it. So
also see whether your finger is on it or not.
Right.
Yeah.
So
that's just a presence sensor.
But still, that's still really cool to me.
Yeah, it is.
So, I actually had to update my phone.
Wait, so does it actually store your fingerprint then?
Yeah. Your fingerprints are stored on here.
Encoded.
It's encoded, yeah.
To the device itself.
And you can turn simple passcodes off, so I have an actual long alphanumeric password on my phone.
Yeah, the fingerprint is actually stored in a chip that's not accessible by the operating system.